Hello, everybody.
Great.
My name is Tom, Zulu Romeo 6 Tango Golf, and today I'm going to be talking a bit about. You've heard Hannes now talk about the linear or the narrowband transponder on the OSCAR100, and I've been experimenting a bit on the wideband transponder for the past couple of months. I'm going to be sharing some of the software that I developed for working on that. And just some basic overview. I'm not going to go into too much detail on the satellite itself. Hannes did quite a good job there. Keep all those parts so that we don't repeat there. So this is the currently my setup on the roof with all the dishes. The picture is slightly outdated. I've actually added a few more dishes in the meanwhile. They grow like mushrooms. So something to be aware of once you start playing with the OSCAR100. So as Hannes mentioned in his previous talk, the QR100 geosynchronous satellite is a narrowband and a wideband transponder. The wideband transponder, which I will be concentrating on, essentially has a bandwidth of 8 megahertz, and it is designed for mostly doing DATV. You'll see there's the basic band plan. We've got our beacon on the left side, which will basically be using to set up for reception. And then we've got the wide and the narrow sections of the transponder. So essentially, depending on how you transmit, you'll either use a lower symbol rate, use less power, be more efficient, but still have good quality. We'll get into more details on that. So essentially, what is ATV or DATV? This is not something that's been very active or popular in South Africa. To my general knowledge, but luckily the OSCAR100 has essentially changed that. Now I have access to a DATV transponder that we can use to make QSOs right around the world, but using video. So up until a few years ago, this has been mostly a analog experimentation, but with the satellite and some of the experimentation that's been done in Europe, they slowly but surely all starting to switch it all over to digital, which makes it a lot more efficient and also a lot more higher quality. So on the QR100, there's quite a bit of lots of cool content. There's regular nets. There's a worldwide net every Sunday. Imagine your technical nets on the repeaters that we have during the weeks. This is exactly like that, except everybody's got video clips to show. They can show their projects. It gets a lot more in depth, and it's quite technical, but in a fun way. So there's lots to learn, and especially with the footprint of the OSCAR100 is it's not all over the world, but quite a big part of the world that participates in these. But the pictures that you're seeing there now is actually all ZS stations that are quite active on the OSCAR100. You've got Gary there, ZS6YI, Henry, ZS6MC, myself, and then also Leon, ZS1 Mike. So we also regularly catch up on the satellite, and it's like the video calling, but via satellites. So, like I said, there hasn't been much experimentation in South Africa around this. It's starting to grow quite rapidly, and we've got quite a few ZA stations now on the satellite. So let's have a quick look, just an overview before we go into the software side, about what exactly you need to receive the DATV. I'm not going to go into transmission. We're mostly talking about reception for now, because like was mentioned in the questions before, the best way to get started on this is to make sure you can receive. The setup is very similar to the narrowband setup that Hannes described there. For the hardware on reception, you basically you use a dish. You also require an LNB, and then the difference is you need a specific tuner to be able to receive them. Now, for the dish side, the difference between the wideband and the narrowband is you actually want a bigger dish. The documentation or the wikis around the internet suggest that you need to have at least 90 centimeter dish to be able to receive the ATV. My own experience is that a 1.2 meter dish at least what you'll need to be able to receive the DATV side. So if you're planning on setting up an OSCAR100 station, based on the talks today, then and your DATV is something you'd be interested in, it might be worth it just immediately going for a bigger dish. If you're planning on transmitting on the DATV, then you'd actually want to go even bigger than that. I'm currently using a 1.8 meter dish for all my transmissions there. But the same setup works for, I'm using the same dishes for both narrowband and wideband. But that's something to keep in mind if you're setting up a new station from scratch. On the LNB side, your restrictions are a lot more less for the DATV. Your simplest standard DSTV LNB that you can get at your local micro works beautifully. It does not have to be GPS disciplined, or you don't have to do external oscillator injections or anything like that. But the one difference between the narrowband and the wideband is your polarization on the LNB. So the narrowband, you need a vertical polarization, but on the wideband, you need a horizontal polarization. And how you switch it on these LNBs is basically the power that you supply to it. So using the bias T, if you send 12 volts to the LNB, then it will be in vertical polarization. But if you switch it to 18 volt, then it will switch to horizontal polarization. But what I did for my setup was similar to the bias T that Hannes described there. But the output or the input of the bias T, normal 12 volt, and then I've got a little switch on there that basically uses an all voltage up, basically pushing the voltage, step up. Sorry, that's what I was looking for. Step up that basically switches it to 18 volt. So I can easily switch between the two depending on whether I'm working on a narrow band or the wideband. And yeah, the LNB basically, again, like I just mentioned, it essentially makes it's down converged from the 10 gigahertz range and brings our signals down to the 739, 740 range. And then lastly, what you need is some hardware. This is a custom built kit. Was designed by the British Amateur Television Club. They're very involved with ATV and DATV, and if you're interested in DATV, that should be your first stop. Go have a look there. The mini tuner kit itself, it's very simple. It's got all through-hole components, no surface mount stuff that you need to worry about. And it's essentially just a tuner module on there with the necessary components to power it and to interface it to your computer. That tuner module is very similar to what you'll find in a DSTV set-top box. Difference being is the range is a lot bigger, so this one can cover the frequency range of 144 megs all the way up to 2.4 gigahertz. You need to, the BATC web store basically sells this kit. Well, they sell the PCB, and then also a few of the components on there are normally harder to find than the rest. So they provide those separate ones as well. That would be the tuner, the computer interface, and one of the voltage regulators. The rest of the components on there is all pretty much standard components that you can get from DigiKey or even most of it from Mantech. It is currently still the cheapest and best option of receiving the DATV. I say it's very similar to a DSTV setup box, but the difference is that the frequency range and then also the symbol rates. One can go down. Using this, you can go down. I think the guys have been experimenting all the way down to 35 kilo symbols. Your normal commercial set-top boxes won't be able to deal with. On the software side, the popular software to use is the Minitune software. This was developed by Jean-Pierre in France. His call sign is Foxtrot 6 Delta Zulu Papa. And the software basically controls the tuner found on the mini tuner. It deals with the various settings and allows you to view the current received transmissions. For all intents and purposes, it works very well. But for me, it had a few drawbacks. Most important one being that it's Windows only. And it's not open source. Now, the open source debate around the software has gone on very long. But one of the reasons for this is probably because the tuner chip that the mini tuner uses is, if you want to get the data sheets and stuff like that, you have to sign a non-disclosure agreement, stuff like that. So I think he's probably just protecting himself by not releasing the code there. But again, this is the easiest way to start receiving. So if you're setting up a new setup, then I suggest you use the software to at least test it and make sure you can do it. For me, I wanted to change things a bit. So we had winter now recently, and with this, like I say, there's lots of interesting nets and transmissions on OSCAR100, but in the shack it can get quite cold. So my mind started to think about how can I get this received transmission in other places in my house, lying in bed, maybe watching it, or in the living room, without having to run, coax from dishes and have mini tuners all over my house to be able to receive it. So I started doing some research, and the first piece of software I ran across is called Longmint. There's no real screenshot there because it's all command line code. There's no graphical interface to it. So this was developed by Heather Longmint. It was designed by Heather Lamont back in 2019. And like I say, it's a command line application with interfaces to the mini tuner hardware, and there's other similar variants as well that it does the same control and configurations as the mini-tune software from Jean-Pierre, but without the graphical interface aspect. The Longmint project has been adopted by the British Amateur Television Club in a lot of their projects as well. And so how it basically works is it interfaces to the hardware, and the video stream that it receives on a valid transmission is made available on a UDP port. So that UDP port can then be connected to using something like VLC. So this was a good start because it meant that I could get the video stream on a network. But the part of that issue was I still needed to be able to control it. So doing some more research, I actually found a fork of the Longmint client, which was done by Phil Crump in the UK. His call sign is M0DNY. And he was basically doing some experiments on adding a web interface to Longmint. Just a little experimentation that he's been doing, so it was still very much a work in progress. But one of the additions that he did was to add a WebSocket interface to Longmint. Now, what WebSockets mean is it's similar to your normal connecting over the network, except it's all accessible from a web browser. So this was basically the last piece that was missing for me to be able to watch DATV all over my house. So the hardware concept that I had in mind was something like this. So you've got your mini tuner, and then instead of having a fully fledged computer, I wanted to use a Raspberry Pi that was connected to the mini tuner, and then the Raspberry Pi was essentially the link to my network, so that it would be connected to the network. The obvious reason for using a Raspberry Pi is obviously it can be a nice little box that would sit in the shack. But also, we don't need a lot of processing power if we're doing it like this. So normally, when you're receiving with the mini tuner, your PC needs to be adequate to be able to decode the video codecs and that. If we use Longmint, then it doesn't actually do any decoding. It basically just receives the signal, and it just makes it available on a UDP port. So whichever PC or device you're going to be watching the transmission on, that will actually be doing the decoding. So essentially, yeah, we've basically got it connected now on the network. That's a little flow diagram just to give the idea. Mini tuner hardware connected to a Raspberry Pi plus the modified Longmint software. That's connected to the network. And then the last piece of the puzzle is the Longmint client. That's the software that I developed on my side. Before we get into that, have a look on what needs to be installed on the Raspberry Pi. It's very simple. You can basically, if you've played with a Raspberry Pi before, you'll probably already have the general idea of how this is going to work. But you flash an SD card with the Raspberry Pi operating system. we tend to use the legacy version. It's best tested one for the different kind of software that we're going to be using. It used minimal dependencies. I've got all the dependencies listed on the actual documentation of the software, but it's basically just a USB interface that you need to install. And then the Longmint gets installed using Git, and then you compile and run it. Simplifying here obviously a bit. I don't want to give all kinds of boring technical terms here, but if you're interested in doing this, then on the website I'll show you later, has all the basic information on there for doing that. And then this is the software that I then developed. So be able to access our little Longmint Raspberry Pi server across the house. We load the software on a laptop, and as long as it can connect to the network, it can receive all the information. The software basically allows you to receive the video signal, and it also allows you to configure the various parameters. So if we have a look at some of the configuration parameters, it starts off by showing you all the status stuff. So we can see what frequency we're listening on, what symbol rate, current state of demodulation, we're locked onto the signal or not, modes, etc. Then it also allows you to actually change the frequency. So there's a bit of a manual control section where you can select the symbol rate and you select the frequency. Send that to it basically sends it over that WebSocket connection to the Longmint server. Then we can also, you'll see, well, the mini tuner that I showed there, it's one tuner, but it can actually decode from two different sources. A lot of the guys in Europe, they do the satellite side on one port, and they do terrestrial DATV on the other port. So it allows you to switch between the tuners. Then the mini tuner also has capability to actually power the LNB. So if you don't want to use a bias T, then you can actually turn on power from the mini tuner. The reason the reason I don't like doing that on my station is because I still want to be able to switch between the vertical and horizontal polarization. So it's almost easier to keep it separate. And then there's also a few basic functions like, controlling the volume. We've got snapshot features. So basically whenever there's a new picture or something coming up, you can snapshot of what you see. Now, one of the tricky things is because we've got the 8 megahertz bandwidth, changing frequencies and symbol rates and stuff like that becomes a bit of a pain. So a software that was developed by Phil Crump from the UK took some inspiration from that. You'll see at the bottom there, it actually shows the whole wideband spectrum as the live one. You guys just know in the demo. And I've integrated the similar idea into Longmint. So it retrieves all that data from the BATC website, and then it shows it live. There's also options for, if you don't want to pull it off the internet, but rather go completely without internet by interfacing it to different SDRs to get that information. And what you're seeing there at the bottom is essentially it shows all the live signals on the wideband transponder. Those are the ones that were live when I took the screenshot there. And you'll see on the left side, with the call sign A71A, that is the beacon that's always running. And then we had two other guys transmitting there, DL9DAC and EA3HCL, that was also transmitting. And it shows the frequency and the symbol rate that they're transmitting in. So if we wanted to view those streams, all we have to do is just double click on the signal peak, click the monitor, and it will automatically send the information to the Longmint server and then tune from there. So it does make things quite a lot easier instead of having to put in manual frequencies and such. Okay, so what I'm going to do is I'm going to try and do a little demo. Got the running here. I'm going to stop sharing this screen and just reshare the screen with the actual client that's running. There. We'll actually share the app there now. Working fine. So You'll see now, yeah, it's going to be jumping like that because I'm actually the stream of the symposium that's now being transmitted on the satellite is actually what we are receiving right now. So let's just switch to another one. So on the spectrum monitor below, you'll see all the different signals. So we can go double click on the beacon, and that's the beacon that's currently running. The beacon is essentially a small little video clip of the actual Falcon launch that put the SA Space, and then there's also some other bits and pieces in between. The beacon is a good way to align your dish. Once you've got a signal there, you tune it onto the beacon, and then you start having a look at your received signal strength. And then we've got our various properties here on the top left side. Sharing my mouse. Oh, it is. Okay. So we've got the frequency on top, symbol rating, it's currently locked on, and receiving DVB-S2. Shows the mode, RF port, and then you'll see there's a big number here, the D 2.5 that it's showing. That's what most of the guys call the D rating, or the D number. What it essentially is your received strength, your signal. Depending on the mode, you need an X amount of signal to be received, the MER. And the D rating shows how much more signal you receive than what you require to be able to decode this video. So at the moment, I've got about 2.6 there, which means that even if it dropped down another dB, I would still be able to perfectly receive the signal without any issues. As you can see, the quality is great. See if we can look at a few of the other signals. So over there, we've got a 100 kilo symbol coming through. That is actually the AMSAT DL in Germany. They're actually doing their symposium today. They're also transmitting. See the little program there. The one here in the middle is our transmission from what we're receiving at the moment. There's Gary 06YI putting out his signal at the moment on 500 kilo signals. Let's explore a bit more. There's another signal there. This is an Italian station, IU4GAV. We're transmitting a test card there now. As you can see, it makes it quite easy to receive the signal and basically view it from not being in your shack. So while I am at the shack at the moment, this is running off a separate Raspberry Pi. Then we've got our basic settings, and we've got some basic debugging screen just showing all the information coming through. Okay, let's explore a bit more while we're at it. There we've got Chris. Chris is, I think he's from Belgium, ON1RC. Transmitting there. One more. DL1LQ from Germany in a transmission there, and you can some of the guys that are transmitting are also showing what they're receiving, so you can actually see a bit of the transmission there on AMSAT DL presentation. Yeah, the software is quite simple to use, and it works quite well. There's quite a few guys on the satellite that's using it as well. Okay, I'm going to stop sharing here and just jump back to station. Okay. So along with, because we can now view all this information over our network, started, as easy as that was, it was still annoying because I had to pull out the laptop and that. So I've been doing a few more experiments. These are quite a bit more experimental stuff. So they're not, you can download it and get it on my site and that, but they tend to break a bit more because it's something I still need to experiment with. So the first one was obviously the obvious Android client. This was designed in Flutter, which means I can, in theory, compile this and make this available on an iPhone as well. Fortunately, I don't have any iOS devices, so it's not something I've been playing with. The one challenge I had here was because of your limited screen, you don't have space to do the same wideband spectrum monitor that shows you all the signals. So it's been designed a bit differently, and you'll see on the left side there you've got various buttons basically come and disappear or reappear depending on whether there's a signal there. So instead of just clicking on the spectrum monitor, you can just see all the different buttons there. It shows frequency and a symbol rate, and you just select the signal that you want to view. The other side of it is, why do an app at all? Why can't we just switch completely to a web interface? Every device that we own has a browser open one way or another. And I've also been getting a lot of requests of guys actually want to be able to stream this over the internet. So they receive in their shack, but they're outside on the road, so they still want to be able to receive it. And the problem with that mostly is because you need to be able to control the long mint for setting it and changing frequency and stuff like that, but you also need to receive the video streamed on a UDP port. Now, if you've been playing with any network type stuff, a port forwarding a UDP stream and WebSockets, and that becomes quite painful. So I started to play with what can we do on the network side. So the original changes that filled it to Longmint already proves that the WebSockets idea works well, but we still needed to be able to show the video. Lots of different web technologies available, WebRTC, RTMP, the whole bunch. You'll get a headache trying to read all of them. But I decided to start playing with a RTMP server. Basically involves the following software components. You've got a web server running an MP module, and the RTMP module can receive a video stream and make it available online in a browser. So to get our video stream into our RTMP module, I'm using something what's called FFmpeg. FFmpeg sorry, is a suite of tools that can be used for processing for video and audio. And then, so in this experiment, I used the command line to convert the incoming feed that we get from the satellite into something more compatible with our RTMP module. So it's outputting it as a H.264 encoded stream, and it's using the AAC codec, which currently seems to have the best results. But I need to experiment a bit with a few more codecs. The downside of this method is that there is a bit more of a noticeable delay, because of the receiving the stream and encoding it and decoding it and that. So if you're watching something like what we're doing now, the symposium, that's not much of a issue. But if you are trying to do a QSO, then it becomes a bit problematic because the other guy has stopped transmitting long before you've even realized that he stopped transmitting and starting. The other downside to this as well is because of the encoding and decoding, this doesn't work so well on a Raspberry Pi. You need a bit more of a decent PC to be able to do encoding and decoding of the video. One of the experiments on my to-do list is basically to use a Jetson Nano, similar single board computer to the Raspberry Pi, but it's got the NVIDIA GPU on it. So in theory, it should be possible to do the encoding on that. Like I say, these are just experiments that I'm still playing with. And then another thing I want to show you guys is you've got the hardware for the mini tuner. Well, the guys in the UK, the BATC guys, have developed another interesting piece of hardware, which is called the Winter Hill. You'll see it looks very similar to the actual mini tuner. This one is a bit more trickier to assemble because it's got the surface mount components as well. Not impossible, but it's slightly more involved in the mini tuner itself. They call this one, the PCB is the advanced receiver. And it basically, you'll see it has little silver boxes. It has 2 of tuners on the circuit board. So essentially, you can decode 4 different transmissions all at the same time. And then another change, what they did was they actually integrated the Raspberry Pi. You'll see it's upside down plugged into the board as part of this PCB. So my little project works out quite well on this, where you've got, it's an all integrated package that's on the network, and it just needed some software changes. The project was originally designed by Brian and Mike, G4EWJ and G0MJW. And the source code they released the source code for this all open on GitHub. So I could hack in the similar the similar WebSocket code that I did for the Longmint client, or what Phil did for the Longmint. I basically copied it over and did a couple of changes and made it work on the Winterhill. But that means that the concept is exactly the same, except now I could change the software and make a Winterhill client. There you can see it was receiving 4 different signals at the same time. Bottom right is my own signal that I was transmitting at the time. And we've also got DL1ZAX, G1LWX, and 2EOLY was also transmitting at the very same time. So that essentially gives us everything we need to be able to DATV anywhere on our network. Got some resources up there. So first off, we've got the software downloads. So if you go to my website there, you can find everything that you need for the software side, how to install it, how to load it, etc. Then if you're interested in the DATV side or ATV side of amateur radio at all, then I suggest you go have a look at the British Amateur Television Club. They've got a huge wiki on there with lots of great information, or anything that you want to get set up and information about how it all works. And then we've also got obviously the AMSAT DL guys. There's a wiki on there as well, and they've also got crazy amounts of information and forums for support and stuff like that. So it's something that's definitely recommended. Okay, and that's it from my side for the DATV network receiver.